Hey everyone, so today we're going to go over acceleration due to gravity. Now let me ask you a question. If you had a rock and a feather both 20 feet in the air and you dropped them at the same time, which would hit the ground first? Now the correct answer is they would both hit the ground at the same time because they're both the same height above the ground and because they both have the same force acting on them, gravity. Now with that in mind, let's try the first problem. A ball is dropped from rest on top of a hill. A. What is the speed of the ball 7 seconds later? B. What is the velocity of the ball at this time? C. How far does the ball travel during this time? And D. What is the displacement of the ball? So this scenario looks something like this. And our givens, we have time is equal to 7 seconds. We have our initial velocity is equal to 0 meters per second. Our final velocity is what we're looking for, and our acceleration is equal to 9.81 meters per second squared downwards. That's gravity. Now let's solve the first part of this problem. We want the speed of the ball 7 seconds later. So our final velocity is equal to our initial velocity plus acceleration times time. So that's 0 meters per second plus 9.81 meters per second squared and 7 seconds. So our final speed is equal to 68.67 meters per second. That's our final speed. But if we want our velocity, which is a vector, we know that the ball is going down, and down is associated with negative. So our final velocity is equal to negative 68.67 meters per second. Now, let's try to get the distance. So the formula to get the distance is Vf squared is equal to Vi squared plus 2AD. Now we have to isolate for D. So we move the Vi squared to the left by subtracting, so we get Vf squared minus Vi squared, and then we divide by 2A. Divided by 2A is equal to D. And so now, when we substitute in, we get our Vf squared is equal to negative 68.67 squared minus our Vi squared is equal to 0 squared divided by 2 and negative 9.81. We get D. Actually, let's solve for D. Let's plug that in a calculator. D is equal to 240.345 meters. Now that is our distance, and then our displacement is the change in distance. And again, since we're going down, it's associated with negative. It's equal to negative 240.345 meters. So not that bad. Let's try the next problem. A ball is thrown downward at an initial speed of 20 meters per second from the top of a cliff. What is the speed and velocity of the ball 6 seconds later, and how far does it travel during this time, and what is its displacement? Okay, so similar type of problem. Once again, it looks like that, but now it has an initial velocity. Let's write out our givens. Our initial velocity is equal to 20 meters per second. Our final velocity, we don't know. Our time is equal to 6 seconds. And our acceleration is equal to 9.81 meters per second squared downwards. So now let's get the speed. So once again, we use the same formula that we used earlier. So Vf is equal to Vi plus At. Our final velocity is equal to 20 meters per second plus 9.81 in 6 seconds. 9.81 times 6 seconds. Our final velocity is equal to negative 78.86 meters per second, and our speed is equal to 78.86 meters per second. So your speed is always going to be a positive number, and your velocity is going to be dependent on direction. So since it's going down, the velocity is negative. That's A. B, we use the same formula we used in the previous question. Vf squared is equal to Vi squared plus 2AD. Vf squared minus Vi squared over 2A is equal to D. Negative 78.67 squared minus 20 squared over 2 and 9.81 is equal to 296.58 meters. 296.58 meters. So our D is equal to 296.58 meters, but our displacement, which is our change in position, is equal to negative 296.58 meters, since it's going downwards. So once again, not too bad. Let's try the next problem. A hammer is dropped from the top of a building and hits the ground 5 seconds later. 5 seconds later, how tall is the building? So let's draw this out. We have building that high. The hammer is coming down. Our time is equal to 5 seconds. Our acceleration is equal to 9.81 meters per second squared. Our distance, we have no clue, that's what we're looking for. And our initial velocity is equal to 0 meters per second. So to do this problem, we use the formula D is equal to VI times T plus 1/2 AT squared plus 1/2 acceleration times time squared. So D is equal to 0 because initial velocity is 0 plus 1/2 9.81 5 squared. So D is equal to 122.625 meters. So we can see that, and if you were to try to find the displacement, it would simply equal negative 122.625 meters. So we can see these problems are kind of repetitive, and they're, once we have the formula and we follow the process, they're very straightforward. So now let's try the final problem. A stone is thrown downward from the top of a cliff at 30 meters per second and hits the ground 6 seconds later. 6 seconds later, how tall is the cliff? So if we were to draw it out, it would look something like this. Our initial velocity would equal 30 meters per second. Our height is what we're looking for. Our height or our distance, same thing. Our time is equal to 6 seconds. And our acceleration is equal to 9.81 meters per second squared downwards. So when we plug the formula in, we use the same one as the previous question. Distance is equal to initial velocity times time plus 1/2 AT squared. This time we have an initial velocity, so our distance is equal to 30 meters per second times 6 seconds plus 1/2 9.81 6 seconds squared. Distance is equal to 356.58 meters. displacement is equal to negative 356.58 meters.